All right, so here's another example that we're going to work on, finding the intervals of increase for this function. It is a rational function. I'm not going to rewrite it now. I'll rewrite it later. Notice this exists for all reals. This exists for all reals, but x equals 0. Therefore, the sum of these two functions exists for all reals other than x equals 0. It's a sum of differentiable functions. Therefore, it's differentiable in the common domain of all reals less 0. So I need to find the critical numbers. Now, you should remember that critical numbers are numbers, domain values, where the derivative is either 0 or does not exist. So this would be 1 minus x to the minus 2, which is 1 minus 1 over x squared, which is x squared minus 1 over x squared. F prime of x does not exist if x is 0. However, 0 is not a critical number. Why? Because x equals 0 is not in the domain. The derivative is 0. That's if and only if the numerator is 0, and you should be able to see that that's at positive and negative 1. So now we make our sign chart. Negative 1 is a 0 of the derivative, 1 is a 0. Look, let's say one of these values is where it didn't exist. You'd see a D&E here. 0 is plumb in the middle. Actually, it doesn't exist at 0, so we're gonna have to be careful there. Okay, and 0, the function doesn't exist. Neither does the derivative. Let's pick positive a half. Okay, a half squared is a fourth, so this would be 1 minus 4, so this would be negative. So the function is decreasing there. At negative a half, the same thing happens. It's decreasing there. Because you should see that, well, I'll bring that up in a second. At 3, 1 minus a ninth is positive. Negative 3, well, 1 over negative 3 squared is 1/9. 1 minus a ninth is still positive. So the function is increasing here, decreasing here, increasing here. Now, I could have pointed out to you, ladies and gentlemen, that this was an even function because f of x was odd, therefore its derivative is even. Now, f is decreasing on minus, open interval from minus 1 to infinity, or I'm doing decreasing, 0 to 1, because the derivative is negative on that interval, so I just plagiarize it. F is increasing on the open interval from minus infinity to minus 1, don't forget the negative 1 like Mr. Isaac, or 1 to infinity, because the derivative, f prime of x, is positive on, and list the intervals. But Mr. Isaac, I want to put these intervals. The AP doesn't like that, so we're going to just make the AP people happy. And there you are. But notice the first part of this journey was finding the critical values of the function so I could analyze the number line, the chart of the domain, so to speak.